Hey everybody, today we're going to talk about how you can use prime factorization to simplify fractions. For some kids, simplifying fractions can be kind of a chore, kind of a pain, especially when you're trying to find the common factor to simplify with. Fractions can really help with, prime factorization can really help with that. So let's see how. All right, so here's how we would do this. To simplify fractions with prime factorization, you're going to want to first find the prime factorization of both your numerator and your denominator. So that's the first thing. Once you do that, you're going to put the prime factorization of your numerator on top of a fraction bar and the prime factorization of your denominator on the bottom of a fraction bar. Then you're going to eliminate the pairs, and whatever is left over is your simplified fraction. So let's look at how that's going to work for the fraction 40 over 120. Part of my prime factorization is actually already there, which is funny. So first we factor 40 and 120. 40 can be factored into 4 and 10. 4 can be factored into 2 and 2. 10 can be factored into 2 and 5. So the prime factorization of 40 is 2 times 2 times 2 times 5. 120 can be factored into 10 and 12. 10 can be factored into 5 and 2. 12 can be factored into 4 and 3, all right, and then 4 can be factored further into 2 and 2. So the prime factorization of 120 would be 2 times 2 times 2 times 3 times 5. So like these points tell us, we're going to put the prime factorization of 40 we're going to make that the numerator in a fraction, and we're going to make the prime factorization of 120 the denominator, all right, and we're going to eliminate the pairs. So this 2 pairs up with this 2, this 2 pairs up with this 2, this 2 pairs up with this 2, and this 5 pairs up with this 5. So all of these factors cancel each other out. What we're left with is a 3 as a denominator, though. So you can't have like nothing as a numerator. You can't have 0 over 3. It's not 0 over 3. What number can you multiply by anything and still get the exact same answer? 1. So we could actually say that this is 2 times 2 times 2 times 5 times 1, all right, and then that does not cancel out, so this factors to 1/3, okay? Let's take a look at a few fractions in action here. It might make more sense if we actually work a few out. All right, so let's simplify 36 and 54. So we're going to start with 36, and we're going to find the prime factorization of 36. All right, 36 can simplify into 6 and 6. All right, 6 can simplify into 2 and 3. So we have both of these 6's simplify to 2 and 3. All right, so the prime factorization of 36 is 2 times 2 times 2 times 3. All right, I'm writing that as a numerator. Now I'm going to factor 54. All right, 54 can be factored into 6 and 9. 6 can factor down to 2 and 3. And 9 can factor down to 3 and 3. So the prime factorization of 54 is 2 times 3 times 3 times 3. All right, now I'm going to switch colors here. So what cancels out? These 2's are a pair, they cancel out, and these 3's are a pair, so they cancel out. So what we're left with here is 2 times 2, which is 4, and 3 times 3, which is 9. So this fraction, 36/54, simplifies to 4/9. All right. Let's try 144 over 180. Okay, 144 can factor into 12 and 12. 12 can factor into 3 and 4. Both of these can factor that far. And then our 4's can, of course, factor down to 2 and 2. So the prime factorization of 144 is going to be 2 times 2 times 2 times 2 times 3 times 3. So that's kind of a lot of terms. Times. All right. 180. We can factor that. Let's do 10 and 18. 10 can factor down into 2 and 5. And 18 can factor to 2 and 9. And of course, 9 can factor into 3 and 3. So the prime factorization of 180 would be 2 times 2 times 3 times 3 times 5. 2 times 2 times 3 times 3 times 5. All right, once again, let's cross out our pairs. So this pair of 2's cancels. This pair of 2's cancels. This 3 and 3 can cancel here, and then this 3 can cancel out with this 3. So we're left with, on top we got 2 times 2, and on the bottom just 5. So 2 times 2 is 4 fifths. 4 fifths. All right. Let's do a couple here at the bottom. 60 and 96. 60 can factor down into 6 and 10. And 6 can factor further to 2 and 3. 10 can factor down into 2 and 5. All right, so the prime factorization of 60 is 2 times 2 times 3 times 5. How about 96? 96 can factor into 12 and 8. 8 can factor down into 2 and 4. 4 can factor down into 2 and 2. 12 can factor to 3 and 4. And 4 can factor into 2 and 2. So the prime factorization of 96 would be 2 times 2 times 2 times 2 times 2 times 3. All right, cross out the pairs. And we have 5 as a numerator. And our denominator would be 2 times 2 times 2, which is 8. So 5 eighths. All right, last one. So 72 and 126. So let's factor 72. 72 could, of course, factor down into 9 and 8. 9 can factor down into 3 and 3. 8 can factor down into 2 and 4. 4 can factor further into 4 and 4. I'm sorry, 2 and 2. All right, so as our numerator here, 72 is going to be 2 times 2 times 2 times 3 times 3. And 126 can be factored down, let's say, well, it's definitely 2 times 62. I'm sorry, 63. And 63 can be factored down into 3 and 21. 21 can be factored down into 3 and 7. All right. Excuse me. All right, so the prime factorization of 126 is 2 times 3 times 3 times 7. All right, so if we cross out our pairs, we have a pair of 3's, another pair of 3's, a pair of 2's. So we're left with, on our numerator, we've got 2 times 2, which is 4, and our denominator is 7. So 4/7 is what that simplifies to. It is a lot of work. You can see I've got a lot of work all over my slide here. But for some people, it might be a little bit more intuitive. It might actually help them to simplify to lowest terms faster. So use it if you like it. Don't worry about it if you don't. But either way, I hope you learned something.